Let's review what we learned last week about scientific notation. Remember that pattern that we had on the board about multiplying by exponents of 10. For example, if you take 3 times 10 to the first, that's the same thing as 3 times 10, which you multiply your non-zero numbers and get 3. 3 times 1, and then you add 1 0. 3 times 10 squared, remember that 10 squared means 10 times 10, which is actually 3 times 100. So you multiply your non-zero numbers, which are 3 times 1, and then you add 3 zeros on the end. 10 to the third power means 10 times 10 times 10, which is the same thing as 1,000. So again, multiply your non-zero numbers, 3 times 1, which is 3, and you add 3 zeros. 3 times 10 to the fourth, you got it, it's 10 times 10 times 10, which is 10,000. So 3 times 10,000, multiply your non-zero numbers, which is 3, and add 4 zeros onto the end. Now, looking at this pattern this way, it looks like scientific notation is a matter of adding zeros onto the end of the number, but it's actually a matter of moving your decimal. On the number 3, your decimal comes after the 3. So multiplying by 10, like we did here, you move the decimal 1 place to the right, which matches your exponent of 1. On 3 times 10 squared, we already did the work, but your decimal on the number 3 would be right here. And if to get to 300, you would move it 2 times to the right, which matches exponent right there. This one, you're moving it 3 times, which is your exponent. And this one, you're moving it 4 times, which is also your exponent there. So remember that scientific notation is a matter of moving your decimal the same number of spaces as indicated by your exponent. All right, let's do a couple of these examples. This is 6.09 times 10 to the fifth. Go ahead and use that shortcut of looking at your exponent. This is a positive 5, which means that you would actually be multiplying by the number 100,000, but you don't even have to worry about that. Just use the shortcut of moving the decimal 5 places to the right. So your number is 6.09, and you are moving it 5 places. So go ahead and draw the loops and make sure you count. 1, 2, 3, 4, 5. So your decimal is going to be here, but you can't just leave those blanks, so you have to fill in zeros, and then make sure that you rewrite your answer so that it looks nice and neat. So 609, 0, 0, 0. Count back every 3 places for your comma. So your answer is 609,000. This second example has a negative exponent, so your exponent is negative 3. So remember, those numbers get smaller, and you move your decimal to the left. So we have 9.712, and I have to move that decimal to the left 3 times. So there's 1, 2, 3. So there's my decimal. I need to fill in 2 zeros, and then rewrite your answer so that it looks clean. So 0.009712. These are numbers written in standard notation. They already are written in the way that we normally write numbers. That's standard notation. So when we write in scientific notation, remember that you have to have a number between 1 and 10. And you just need to strategically place the decimal so that it becomes a number that's between 1 and 10. On this first example, 98 million, there is only one place where you can put the decimal to get a number between 1 and 10. Any other place you put it, it's going to be less than 1 or more than 10. So that needs to be 9.8. 9.8 is between 1 and 10. So now we need to figure out how many places we're moving our decimal, and that becomes our exponent. So remember, this is where the decimal would be on 98 million. Well, we moved it to here. So just go ahead and count how many times you'd have to move that decimal, and it's 1, 2, 3, 4, 5, 6, 7. So it's 9.8 times 10 to the 7th. And you can kind of cheat and look and see that that's a really big number, so your exponent is going to be positive. On the next number, it's a very small number. We still need a number between 1 and 10, so the only place to put that decimal would be between your 1 and 5. So that becomes 1.5 times 10. Then let's see how we'd have to move that decimal. So we'd have to move it 1, 2, 3, 4 times to the left. So that's 1.5 times 10 to the negative fourth. On this last example, you need to first write this number in standard notation, so how we normally write numbers, and then go ahead and write that in scientific notation. So 5 million is a 5 with 6 zeros following it. So there is the number 5 million. And you can double check your place values. Here is your ones, tens, hundreds, thousands, 10,000s, 100,000s. So this is your millions. So that's 5 million. So then when we write it in scientific notation, you need a number between 1 and 10. Well, we can write that as the number 5. And it's going to be times 10 to, well, if we put our decimal here, you'd have to move it 1, 2, 3, 4, 5, 6 places to the right. So there it is in scientific notation, 5 times 10 to the 6th.